Hey, welcome back everyone. Now we do have the slides, but we don't have good audio anymore. So we're working with the mics on the webcams. So sorry about that. We had a lovely pizza. Not as good as the one that Ernst made for us last time in the Netherlands, but always stuff left to improve. New goals. So for our second external speaker of the day, Marko, welcome. You're from Ritchie.
Yes.
But you were going to introduce that.
Yeah.
Let's start right away.
Sure.
Okay, good luck.
Great. Thanks. So yeah, I'm going to talk about some random things about mobile app ads. And I'm Marko Karppinen, and I'm from a company called Ritchie. I run it and I own it. And what we do is we have a advertising product called Ritchie Ads, which is an ad serving technology mostly for native applications. So we're an SDK-based solution, and we mostly focus on full page, full screen ad units. We've been at this for about 3.5 years now, and our tech is mostly used by magazine and newspaper apps. So that's the background. And I basically have 6 small things I want to share with you today. And kind of the first thing is that swipe UI, or using apps by swiping, is the big difference that makes full screen ads work. And this is something that wasn't true on all desktop sites typically. So full screen ads were tried there. They were called interstitial. The problem with them was that navigation on traditional desktop websites is purposeful. It basically means that the reader comes to a website, sees the front page, sees a bunch of interesting stuff on the front page, chooses something to read purposefully, taps on that, expects to get to the thing that they chose, and then they encounter an ad instead. And that's how interstitials used to work. That interrupts the user, and that's horrible. But the great thing about swipe UI is that the navigation model that users have when they swipe from one page to the next is not as purposeful. They're kind of browsing in the original sense of the word. So when a user is in that mode and encounters an ad, they're not really interrupted, or they don't really feel interrupted. And it's much more like in print newspapers and magazines, where it's natural to encounter full page, full screen advertising in that context. So that's the kind of, I think, big difference that we are encountering now. The other great thing about native applications, or ads served in native applications, is that we can reliably preload them. So in our platform, for example, ads are just normal or pretty normal HTML5 websites that we just zip up and download to the app in the background. And the key thing is that we do this only once per the campaign duration. So if there's a campaign that's going on for a week, the ad creative will be downloaded a maximum of once per week for a given user. And that's a huge win, because it means that ads can be huge in relation to kind of the traditional way of web display advertising. So whereas kind of a 50 kilobyte banner creative size is on the high end of typical web creative sizes, but it's just not good enough. It's not big enough. Mobile phones these days have full HD screens, and tablets have even bigger resolutions, and you just cannot make a high quality presentation or high quality creative in 50 kilobytes. We need more size. But the ad will need to be downloaded, and the only way to get that big ad to the user is to download it in the background asynchronously. And when we do that, it no longer matters how long the actual download takes, because the users never wait for it. So we can get like this figure is, it's 100 times bigger creative sizes, and that made a huge impact in terms of the effectiveness of the advertising. This has a couple of implications, and the first one is that things like RTB doesn't really work in this context, because the key difference in serving ads this way, the way our platform works, is that each and every ad that we display has been downloaded in advance, typically well in advance. So we might show an ad on Friday that was downloaded on Monday to the user's device. So this is about as far as you get from real-time bidding. So typical real-time bidding implementation has bidders, a typical implementation gives bidders about 120 milliseconds to decide how much they want to bid on an ad impression. And when we're talking about ad creative, that's like 5 megabytes or bigger, it's obvious that you cannot do that download in that time. So you cannot arrange for that bidding to happen in real time unless you want to just in case download all the ads in the world in advance, and that's just the cost doesn't make sense. And kind of in a similar vein, this affects the targeting logic as well. So if you look at online display advertising, the ad technologies used on the desktop, they're typically all about targeting. Because that's kind of the only knob that you have to toggle in that business. But that's also because kind of web display advertising doesn't work without targeting. It's notoriously bad in terms of how well a simple web banner ad does in terms of engagement if it's not really accurately targeted. But we found that full screen rich media advertising on mobile works without that hyper accurate targeting, because when the ad's full screen, it doesn't compete with the content at any point for attention, and with the big file sizes, the production value is such that it can be really compelling as content. So so we find that targeting doesn't really improve things to the level that we see on the web, and that's why it's almost not on our radar at all at this point. So in terms of technology, this is actually really simple. It's about actually delivering the ads. So we are talking about 5 megabyte ad creative for an audience of 10,000 or 100,000 or a million users. Kind of the bottleneck is just simply delivering that ad the moment the campaign starts. And the problem is not really the overall traffic volume, it's that the peaks in that volume are much pointier with this approach, because especially if and when we're selling time-based campaigns for a week, for example, a huge portion of the audience will download the ad creative, that 5 megabyte zip package, the moment it actually goes live. And that means that you have 10,000 or 100,000 people hitting those servers at once, trying to get that package. And it might be one of 10 ads that launch at the same time. So you might have 50 megabytes in there. So kind of the technical challenge in serving ads this way is just basically about the kind of mechanical delivery of them. So I have a couple of kind of simple lessons about that. The first thing we noticed is that actually having that native SDK, having our own code running on the client without the limitations of kind of a browser runtimes means that it can be the client itself that kind of orchestrates the whole thing. So the individual units on the server that kind of implement this functionality, they can be really, really independent of each other. And that means that we can kind of use server-side solutions that are a really good match for each individual part of the whole. Because if you look at the different parts of this, which is like analytics gathering, or the actual metadata of which campaigns are live, or the actual download of the ads, those different parts have very little in common. And if you can implement them completely separately from each other, then it gets a lot easier to build an affordable but performant, reliable solution. So in our system we have, or the SDK talks to these completely different services that have completely different backends. So we have a different endpoint for the metadata of which campaigns are running right now. We have a separate service that does nothing but grants out unique tokens for the clients that we can then later use to track individual users in the analytics. We have a completely separate system for receiving analytics events from the apps, and this is decoupled from the actual viewing of the creative and the actions that the users are taking, so that the analytics part works even offline, because it just stores data locally on the clients. And then we have the downloading of actual ad packages, which is that's the performance critical part, but it's also it's just about downloading files. And so these different parts have very different requirements in terms of how they need to behave. So the analytics gathering, for example, we cannot lose that data. It has to be durable. But we don't have huge uptime requirements or reliability or availability requirements for it, because if it goes down for 5 minutes or 10 minutes, that's essentially harmless, because the clients will just keep retrying to send that data, and it all happens on the background, so it doesn't affect anything. Kind of the only thing that really needs to stay up all the time in this infrastructure is the campaign metadata that tells the client which campaigns are running. So that needs to stay up, but it's so cheap to do in terms of CPU power required that it's trivial to build a really reliable implementation for it. So we have the metadata endpoints, for example, in Heroku, and a $35 a month Heroku Dyno serves hundreds and hundreds of requests per second with this workload. So it's really, really trivial to scale up. And finally, the ad delivery part is just static file serving. So there's nothing nothing that's difficult to understand about the problem of static file serving. And it's something that you can just, if you want, you can just use a CDN for that stuff. But we found that actually, even with our user base of just tens of thousands of users, it's much better for us to roll our own static file serving infrastructure in terms of the cost. So what we do is we have our own servers on each country, or it depends on the network topology, but close to each target audience we have our own file serving infrastructure, and then we have a fallback to CDN if we can't keep up with the load of that. So kind of that's the way we ended up building this thing, and I think the key point in terms of how we built this is that it really helps to have a clean slate. We started this 3.5 years ago, and nobody in our team had any experience with serving ads online. So it's everything here was new for us, and that means that, or I think that really helped us to kind of reason from first principles in terms of what we should do, what are the kind of key attributes of this thing, and how this thing should be built. And I think that's really the key thing about all new mobile ad serving technologies, where it's not that the technology is so different that we ended up doing things completely differently, but it's more about it's more about just getting that kind of second chance to think things from the ground up, to rethink stuff and do new implementation without any of the package of the old stuff, and that's basically what we've done. So thank you. Follow me on Twitter. That's the extent of my commercial part of this. Thanks.
Thanks a lot. Any questions? Yeah.
So it's like static file serving.
Yeah.
That really makes up that delivery. Can that be also done in mobile clients space in the with some kind of background agents or scheduled jobs that even remove the past from the equation, so that
yes,
files
absolutely.
at your convenience at night, maybe even context aware that if Wi-Fi is on, you can kind of like know.
Absolutely. So it, of course, we might have time-sensitive campaigns running. So even though it's not about, the users swipe the page, so we better get an ad up really quickly. But if a campaign launches today, it should probably be visible to the users today. So that's kind of the extent of the time pressure there.
Yeah.
And so currently, we cope with the peak of our 7 a.m. on Monday traffic, which is what happens here with Helsingin Sanomat, where they sell 10 weekly campaign slots. And so the typical user starts to download the ads when they first launch the app on Monday morning. And that's like a really, really narrow peak, 7 a.m. each Monday. But if that turns out to be a problem in the future in terms of just bandwidth issues, we have like 10 gigabits of bandwidth there, and if that turns out not to be enough, then I think what we can do is spread that load throughout the night with push notifications or background downloads and stuff like that.
The background agents typically run like every 20 minutes or 30 minutes depending on the platform, and or with Android it's a bit different even. And point being that if that's not time critical, then it could be done this way. But then again, another cost up either that way or then CDN. Whichever is cheaper.
CDNs I don't know what your total volume is, but for us, we're kind of in the bracket where CDNs are really expensive for us, where we have significant volume, but not enough to get huge discounts from the CDN vendors. So we're kind of there in the middle where it really pays off for us to build our own infrastructure. But I'm not sure whether that will be true in the future as we grow, but that's the current situation.
You said that full page ads work really well for sort of browsing experience. How do you see that transforming or transporting into the task-oriented apps or games or things like that?
I haven't seen very good solutions on that front. And it might be that we're a bit myopic because we're really focused on this kind of magazine, newspaper centric use case. But it kind of, to me, the key key aspect of our results has been that the users don't find that these ads interrupt them, and I can't see how that would be true in a gaming scenario, for example. So it kind of, I think it changes the advertisers. You cannot sell advertising like that to brand advertisers, for example, because it's so critical to them that they're not annoying users, and it probably sells the sort of creative that gets used as well. But I think from a kind of perspective of a newspaper or magazine publisher, the key advantage of this is that the strengths, the natural strengths of the print advertising side are there. So this is something that's really easy to leverage when selling digital advertising to existing print customers. But yeah, it's going to be problematic with games and task-oriented apps for sure.
Okay, final question for Marko?
No.
Okay.
Okay.
Thanks, guys. Was Lasse, because we have a change in the drill there?
Yeah.